Hello, everyone. My name is Albert. I work at Canva, an Australian company that runs a software platform to empower the world to design. But today, I'm here to talk about Kickoff, which is a side project of mine that started basically as my attempt to solve a problem that we continuously see Canva engineers struggle with, especially when trying to build applications with Python and Bazel. So if you allow me, let me use a little user story of what this problem is about. Let's imagine we have Adam that decides that his team has a very manual operation and he wants to automate it by creating a very small Python application. And he decides to use Bazel to build and package this application before he can ship it to the rest of his teammates for them to use. After a few iterations, he manages to get to the state where he can run Bazel run and gets the application running on his computer as he was expecting. Then, super happy about the results, he goes and packages his application by tearing up the output directory that Bazel has produced and uploads it to his personal server and runs to his colleague Alice to show her that now this manual operation is no longer a thing and she can actually use Adam's application to basically get that done more efficiently. Super happy Alice goes and downloads the package application from Adam's web server and runs a few commands that Adam helps her with to install this application on her laptop, which, by the way, is the same platform as Adam. So they basically share the same computer settings, like the same operating system and CPU architecture. But unfortunately, even with those similarities, when Alice tries to run the application on her computer, she's greeted with not so great error message that says, oh, Python 3, no such file or directory. And both Alice and Adam are pretty sad about this because one of the reasons they use Bazel for is like all these hermeticity and reproducibility guarantees that just so happens not to be that visible in here. And the same way Alice and Adam were asking why, you might also be asking why this is happening. Well, turns out it's not that really Bazel's fault in this case, but if we look at the output directory, the Py binary from rules Python output, you will quickly see where the problem is. So if we look at the run files tree here, you can see this suspicious app file that you would expect to be a binary that can be natively launched in the target platform, which effectively, out of your surprise, is not actually a binary. It's a Python script that contains a very offending shebang that turns out to be resolved in the target platform. So even though the run files tree contains a fully fledged Python interpreter, something in the target platform needs to do the work of actually finding this Python interpreter in the runs files directory, and then do all the heavy lifting of launching the application with this interpreter. Unfortunately, this creates kind of like a chicken egg problem of, well, if we have the Python interpreter within my run files, but I need a Python interpreter to find it, which Python interpreter can I use? And in this particular case, the easiest solution that the RuleSpy authors seem to have landed on is just assume that there will be some form of Python interpreter installed in the target platform, which in the case of the poor Alice didn't happen to be. In terms of specificity, there's a little bit more going on in this bootstrap script in here, but roughly can be summarized as like this pipeline of shell commands here in terms of what this logic does. The question I asked myself after figuring out how all this stuff worked and why our developers were facing this problem is like, can we do better? And thankfully, the answer is yes. But before we introduce everyone into like what can do to make this better, I wanted to take a step back and see like what would the ideal solution would look like in case that we can live in a perfect world. Well, in an ideal situation, we really want Bazel to be able to produce a binary executable for all the target platforms that we want our application to run in. And this binary application has the logic to actually perform this bootstrapping before the Python application is actually run. By having a native binary, what this effectively means is that the system interpreter no longer matters. And in fact, this can be run in a particular computer where there's no Python interpreter at all. And instead, the interpreter comes as part of the bundled run files that we ship to our users. With that in mind, I started exploring with different alternatives because on the slide before, this kind of looks like a cross-compilation setup. And cross compilation sounds like a very complicated thing to set up, and especially for rule set authors for interpreted languages to have to deal with. So is there anything else that we can do that may avoid the need for a cross compiler? So as we've seen in the previous talk, some rule sets have decided to, instead of depend on the Python interpreter in a system, instead depend on bash or a POSIX shell, which is usually like way more likely to be in there. But still in Canva, we found some problems with this approach when trying to run the same application within a Scratch container that might not even have a POSIX shell. That brings us to the next alternative, which is to use containers. With containers, we can use the container runtime as this native launcher that knows, hey, by the way, the Python interpreter is in this run files directory, and I want you to launch this container using this particular path, and therefore everything works. And this works very well for binaries that are meant to be run on the server side, because we can control the fact that the container runtime is installed, and we can also make sure that everything is set up for the application to work correctly. But it might be a little bit of a more problematic alternative if we plan to ship these applications to client side, because our users might not even have a container runtime installed, or if they do, sometimes if they run a CLI tool locally, they might expect that it can see some files in the file system or even reach through the network, and the process and network and file system isolation that come with containers might get in the way. So after evaluating all these possibilities, I kind of like going back to, well, it turns out that really the solution that works better here is a native launcher, but the cross-compilation aspect of making a native launcher is kind of like really the problem that I'm trying to solve here. So I started thinking, can I actually emulate the idea of having a cross-compiler without having a cross-compiler? That was a wild idea until I actually stumbled on the fact that executable binaries formats for all major operating system, ELBS, macOS, and P32, turns out to not care about arbitrary data that can be appended at their end. So what I did is I built Kickoff, which is this particular launcher that is basically a collection of runtimes that are pre-built. They're pre-built using Rust, which can target multiple target platforms. And using this knowledge that I got that binaries for the major operating systems don't care about arbitrary data being appended at the end, it allows users to basically inject at the very end of each of these runtimes a JSON manifest and a trailer to tell the runtime how to actually read this manifest with like the starting point and the length. And therefore, when this runtime executes, all it does is it reads itself, reads the manifest contents, and therefore performs an execve call with whatever it finds in this manifest that has been previously specified by the user. So in reality, this is just like a pre-configured execve call that reuses the same runtime binary every time for whatever application we want to run. However, sandwiching bytes as this might be a bit complex, and especially if you're not familiar with like how this trailer should look like. So it might not quite cut it for rule set authors in Bazel. So I was like, can I do actually something that helps them produce those launchers and do the sandwiching of bytes? And that's why Kickoff also comes with a CLI that is a very simple like CLI logic that embeds all the possible runtimes for the target platforms that we currently support. And it allows a very easy interface to basically construct one of these sandwich of bytes that will eventually become your native launcher on the target platform for whatever system, for whatever application you're building. So from here, the real question is, well, this is ready to use, but like what are the next steps that I would like to take to make this a bit more production ready and perhaps even make it like something that rule set authors can use more easily? One of the things that I have to say is that currently the runtimes for Linux still depend on the target platform being a glibc-based platform, because I didn't manage to build the runtimes against Muscle, but that's something that I plan to actually fix. Maybe I can also provide some Starlark APIs, so rule set authors can use like toolchains to bring in all these runtimes and then call certain like Starlark functions to construct these launchers in a very user-friendly way. And of course, right now I don't support platforms such as FreeBSD, which if there's appetite, obviously they can be added in the future. The project is available in GitHub. It's totally open source, so contributions are welcome, feedback are welcome. Also, this is like my first project in Rust, so anything that you can contribute to make this like the code better, I would really appreciate. And yeah, that's all from me. Thank you very much.